Scientific notation is a notation that scientists use to write very large or very small numbers to make them easier to read. So let's start with this number. It's a big one. It's 53,809,000,000,000 whatever cats. A lot of stuff. This is actually a really hard number to read because you have to kind of count up the zeros to find out where you are. So what we could do is write it like this. We could say it's 5.3. Actually, we could do it like this. We could say 53,809 times a 1 with 9 zeros after it, which is also kind of a bit awkward to read, so let's make it even simpler. We could say it's 5.3809 times 1 with 13 zeros after it. And to make this actually look simpler, we can say that equals 5.3809 times 10 to the power of 13, which is just 10 times itself 13 times. This is scientific notation. It is made up of the coefficient, the base, which is always 10 when we're writing scientific notation, and the exponent. And for a big number, this will be positive, and for a number which is really, really small, that will be getting into the negatives, and we'll show that example in a moment. A short way of determining what that exponent is to start at the end of the number and count how many jumps you need to get to between the first and second digits. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and that's where the decimal point would go. So it's 5.3809 by 10 to the 13. Here's another example. There we go, it's something less than 1. And again, what we can do is start this time at the decimal point and jump until we get to between the first and second significant figures there. So there's 1, 2, 3, 4, 5. So because we're jumping to the right there, we know it's 10 to the minus something, 10 to the minus 5. You'll notice that in scientific notation that the number of digits in the scientific notation number is the number of significant figures. So actually in both of these cases there are 5 significant figures. I'll just underline them in red. 1, 2, 3, 4, 5. Now we're assuming, I've just noticed here, that none of these zeros are significant. So maybe I've specified that in the question. If I hadn't, I would need to add some more zeros in here, so I would make sure that I had the correct number of significant figures. So that is a little complicating factor. But let's assume we are given this number and told that it is 5 significant figures. So our final scientific notation written here has 5 digits in it times the base to the power of the exponent. Again here, this underlining in red, the significant figures, 1, 2, 3, 4, 5, and we know that last one is significant because if it wasn't, we could just drop it off the end, it wouldn't change the number at all. And so all of those 5 have been transferred over to the scientific notation version of that number. So that is scientific notation, and it is actually a very useful thing to use when we're doing lots of calculations. Sometimes you'll see written, especially in spreadsheets, or if you're using Excel or Google Sheets, and even on your calculator, that these numbers won't be written with a multiply 10 to the power of something. They'll actually be written with an E. So if I write this one again down here, instead of you seeing on your calculator 2.3080 by 10 to the minus 5, it would be written as 2.3080 E minus 5. So just keep that in mind, and you can use the little EXP button on your calculator to make it easier to put in scientific notation.